that is measurements which are in something dimensions only. So measurements, when we're talking about length, how many dimensions is that? This is one dimension only. So what about when we're asked to find, instead of one-dimensional lengths, we're asked to find areas of similar shapes instead? That is, measurements which are in 2D space, so two-dimensional space. So the fact that there's two dimensions kind of plays a part in the maths, particularly in terms of this thing here. Okay, so this is worth actually reading over. So it says, if a figure is enlarged with a scale factor k to produce a similar figure, then the new area, this is an important little formula, the new area is equal to k squared multiplied by the old area. So remember, actually, I'll colour code it in a different way. So remember, like when we were doing transformations, I tend to do the new image, like the image, for example, I would do in purple. And the object, the original image, I would do in red. So I'll be using these kind of colour codings if the board will cooperate with me. What's really important is you need to square the k for your problems. So the scale factor, because it's two dimensions, we need to square k. Square the scale factor. Whereas before we were dealing with just one-dimensional length, the new length would just be scale factor multiplied by the old length. Because we're dealing with two-dimensional space, the new area would be k squared multiplied by the old area, of course. So let's see how that applies to an example. Here we go. So I'll be using, as I said, this kind of purple and red colour coding today, if the board cooperates with me. Okie dokie. So what we've got here is we've got figure A and figure B respectively have areas of 160 metres squared and 90 metres squared. This is important information that we might want to write on here. Given that the figures are similar, find x. So notice x is one of the missing lengths. So in order to find x, we're probably going to need to work out what the scale factor is. And we're going to use the areas and the formula above to solve for the scale factor. So let's label a few things. I'll just give ourselves a bit more space. So let's label a few things to start with. So remember, this is the original shape, and it has an area of 160 metres squared. Okay, whereas this one is the new shape, and it has an area of 90 metres squared. And given that the figures are similar, we need to find x. So as I said, we need to work out what the scale factor is. What shapes are these, by the way, out of interest? Do you remember what kind of shapes these are? It starts with T. It's right there, the trapezoid. So what we're going to do, as I said, we need to work out what is k. And we do that right out of the What is k? So I tend to think of that, instead of k being the new length over the old, because remember when we find the scale factor, normally we would do the new length over the original length. Similarly, when it's an area, we can say that k squared equals the new area. Remember, the new area is always on top. K squared equals the new area over the original. Sometimes people call it the old area. So if k squared is the new area over the original area, we can work out a little equation. So let's say, and we can solve for k. The thing to remember is it's k squared, not k. So the new area was 90, and the original area, what was it? It was 160. So you could start to simplify the fraction. That's maybe one thing you could do. Let's see if we can do that, if it's going to let me store down. Okay, so k squared equals 9 over 16. therefore K equals 9/16 square rooted. And going back to thirds, so we need to think back to thirds now. So thinking back to thirds, how can we break up the square root? We can go to K equals square root of 9 over square root of 16. So the square root of 9 is easy enough. 3 square root of 16 is 4. So brilliant, we have K. So K is 3/4. And so now it's going to be easy. We can find the missing length just using the scale factor K. So let's go up to the side, and now let's find two separate parts. So we're going to work out, now find X. So we can say K, what sounds 3/4, just going back to, K is equal to the new length, because K is K squared, new length over the original length. According to our diagram above, the new length is X and the original length is 24. So let's sub in what we know K is. We know K is 3/4, split that out, and the new length is X, and the original length is, what was it again, 24, according to the diagram. And then we get to use a lot of cross multiply in these weeks. We're going to cross multiply, it's good practice for that algebra skills, cross multiply and solve for X. Now, I just need to scroll down because I've got a funny board. Lovely. So 3 times 24, if you want you can write it out. Let me just make a second note. 3 times 24 equals 4x. Cross multiply. So 3 times 24, I'll give you a moment to think about it. 3 times 24 is 72. So 72 equals 4x. So x is got to be 72 over 4. Have a think, how many times does 4 go into 72? We could break it down to 36 over 2, and then 36 over 2 is 18. So units, have a look at the diagram above. That's right, it's meters. So I'm going to make a note. So don't forget your units, you don't want to lose a mark after doing all that math, just to not have a negative. Tragic. So there you go, that's a reasonably easy one. One thing to note as well, that remember when we're finding square roots, so square root is positive and negative answers. So square root of 9, there's positive and negative 3. Square root of 16, there's positive and negative 16. But in this context, we're talking about scale factor, and we're not allowed to have, sorry, okay, second life again. Nope, no it's not. Let's pause the class again. So thanks again for your patience. Okay, so what I was talking about was the fact that we need to reject the negative answer to the square root. Okay. Interesting. So you might just write that. So I know if I'll write it. There you go. Reject the negative answer. Reject negative answer. Okay. Because in this context we can't have a negative answer. We would have negative lengths and all that kind of thing. So that's why we have to reject the negative answer for now. Okay, let's continue on. So in this example, in the given figure, we seem to have some similar triangles going on. So in the given figure, AE equals 3. The triangle ABE has an area of 5 centimeters. That's this one here, centimeters squared, sorry. And BEDC, notice that's not the other triangle. That's what I mistakenly thought. I thought it was the other triangle, but I'd look carefully. BEDC is this quadrilateral. So it's this trapezoid here is equal to 6 centimeters squared. So 6 centimetres squared is not the area of the big triangle. 6 centimetres squared is just this part. So the area of the entire big triangle would be this area plus that area. 5 plus 6, 11 centimetres squared. You're asked to find the length of ED, correct to 3 sig figs. So I'm guessing what we're going to have to do is work out, using our scale factor, we're going to find a scale factor. We're going to end up working out what this entire length is here, and then we're just going to subtract 3, because they tell us AE is 3. So to work out this length, it'll be the entire length AD minus 3. So we're going to first of all have to find the scale factor, and then we're going to have to find AD. So let's start to draw out the two triangles. That's always a really, really good idea. And notice also we've got some parallel lines. Maybe that's kind of significant, maybe not. Okay, so let's draw our little baby down. So I'm going to draw the little one first. A little triangle. And label it A, B, B. And mark in any length we've got. We know that this one is 3. And we know it's got an area of 5 cm squared. So that's our original. That's why I've done it in red. You could have done it the other way around, but I'm choosing it to do it this way. I personally find it easier to put the original as the one that we know the length of. Then let's do big one, which we know fewer lengths of. So we've got A, B, and C. A, B, and C. The only thing we're thinking about this one at the moment is that it's, in total, the area of this one is 5 plus 6. That one's 5. 5 plus 6 equals 11. So 11 centimetres squared. And what we need to do is we need to find out what this whole length x is first. And then to find out, then from that we'll be able to calculate this, because we know that this length here is 3. So we're going to find x first of all. And in order to do that, we need to first of all work out k using our areas. So remember k, oh, I forgot to do this one. This one is the new one. So remember, k squared is the ratio of the new area over the original area. We're going to use that again. So k squared equals total new area, the width on the top, and the original area on the bottom. Same thing for length. You're probably guessing for the next lesson volume scale factors. Same thing, except it's just going to be k cubed equals new volume over original volume. Same kind of idea. And now we can start to plug in those numbers, as we know those two areas. Okay, so the common mistake is people would misread and think that the purple area is 6, but it's not. 6 plus 5. So that's 11 over the original area, which is 5. Okay. So it looks like we're going to have a slightly awkward dirty kind of scale factor, but that's fine. Whatever you do, don't think that you need to work it out to lots of decimal places. Just leave it as 11 over 5 square root. That doesn't simplify, but no problem. We can just leave it like that. And of course, we reject the negative count, or put it up as negative x, which doesn't happen in the real world. So our scale factor is square root of 11 over 5. Please just leave it as that for now. Don't work it out as a decimal, because you might get a reasoning error in the end. So now what we need to do is we need to work out what x is, and then don't forget we then need to work out what that is by subtracting 3 from the answer to x. So now we're going to find x. Let's divide this off so we can have some logic to what we're doing. Okay, so now we're going to find x. And just a little note here, you might also say, to find ED, let's stand for we need first find x, and then subtract 3. Just so when you look back, you sort of see what you plan to do. Now it's time to find x. We can use the scale factor is equal to the it's always the new length, one dimension length, k, not k squared, new length over original length. And we know our awkward scale factor is square root of 11 over 5, so just put it in like that. And new length, let's say looking at our diagrams, new length is x. The original length on our diagrams above is 3. And that seems a bit weird, I know, but it doesn't matter. Because x, you just need to multiply square root of 11, square root of 11 over 5 by 3. So you could do square root of 11 over 5. Fine. Oh, you could also have a multiply sign in there, that's totally fine. Try putting that in a calculator. On the Inspire, I'm not sure, you might need to put in 3 multiplied by square root of 11 over 5. And then you've got an answer. You write out lots of decimal places. Or you could go straight to saying, so ED must be x minus 3, which is 3 square root 11 over 5. Actually, that looks like the cube root, so be careful of that. So maybe you want to do that 3 multiplied by square root of 11 over 5 minus 3. So ED. Oops. Equals. And plug that into the calculator. Write it out to lots of decimal places. Let's see, what do you get? You get 1.447972 dot, and then round it to 366. What would that be to 366? That would be 1.45.